session we study about the nature of roots of the quadratic equations. Here you see we have the general form of quadratic equation is x square plus bx plus c is equal to 0. In the last session we have studied about the derivation of the formula x is equal to minus b plus minus root b square minus 4ac over 2a. Here you see b square minus 4ac, which is under an square root, is called the discriminant, which is denoted by capital D. So discriminant is equal to b square minus 4ac. It classifies the nature of the roots of the quadratic equation. If this discriminant is greater than 0, we get it is positive, then we get real and distinct roots. If this thing is positive, then we will get two values, one from this positive sign and one through this negative sign. So we get two values which would be real and distinct. If b is equal to 0, if b square minus 4ac is equal to 0, so we get the minus b over 2a, which is the only one root we will get here, or we could say the real and equal roots. And if b is smaller than 0, it is negative. If you get any negative number inside this square root, we get the imaginary number. It is called the imaginary number. So we get two imaginary roots, one taking positive and other taking negative. Yeah. So in this way, we get three we have seen that the nature of roots of three sort of roots we have seen here. The real and distinct roots, real and equal roots, imaginary roots. Now I explain you geometrically how these roots comes. You see here, real and distinct roots, d is greater than 0. If d is greater than 0, we have a function like this, y is equal to ax square plus bx plus c. This is a function, quadratic function we have. Now, if we get y is equal to 0, assume that y is equal to 0, so the intersecting points on x-axis it will show. The value of x would be here and the one root would be here. So we get two roots here, the two distinct roots. If we put this x square plus bx plus c is equal to 0, we get two values of x. If d is greater than 0, then we get two values, one is here and one is here. This is our x1 and this is our x2. Or we could also say that this is our alpha root and this is our beta root. So in this way we could get two roots through this quadratic equation if d is greater than 0, real and distinct roots. Now I would like to explain if real and equal roots, if d is equal to 0, so we get that because we know that x is equal to minus b plus minus square root d over 2a. This is our equation, b square minus 4ac, we are putting d capital D here. So x is equal to minus b plus minus 0 over 2a. So what we get here, x is equal to minus b over 2a. There is only one root we are getting here. This is the repeated root. We could say real and equal roots. We could say this. Now, if we see the imaginary roots here. So in imaginary roots, d is smaller than 0. We know that x is equal to minus b plus minus root. The d is negative, minus d over 2a. If any number which is negative in under any root is square root fine, so it is called the imaginary. So one we are taking through this positive sign, other we are taking through this negative sign. So we get two imaginary roots here. It means that this intersection of x-axis and this function is not on real line, it is some imaginary point it intersects the x-axis. So it is the imaginary roots. Now we study about the sum of roots. We already know that x is equal to minus b plus minus square root of d over 2a. We assume that if we take the positive sign here, we get alpha. Alpha is equal to minus b plus square root of d over 2a. And if we take negative sign here, we get beta. So beta is equal to minus b minus root d over 2a. So this we are writing here. Now we have to find the alpha plus beta, which is equal to minus b over a. We have to derive this. So we are adding this is our equation 1, this is our equation 2. Adding equation 1 and 2, adding equation 1 and 2. So here we get alpha plus beta is equal to minus b plus square root d over 2a plus minus b minus square root d over 2a. Look at this. 2a is in the both denominator there is 2a, so we get it common in denominator 2a minus b plus square root of d plus minus b plus minus square root d. So now we get here d is positive and this square root d is negative. Now we get here minus 2b, minus b and minus b with minus 2b over 2a. Here you see 2 will eliminate each other, and finally we get here minus b over a. So alpha plus beta is equal to minus b over a. So this we have proved that alpha plus beta is equal to minus b over a. Here I would like to explain one thing more, because we know that ax square plus bx plus c is equal to 0. This is our general form of the quadratic equation. Here you see b is the coefficient of x. So we could write that alpha plus beta is equal to negative of the ratio of coefficient of x over a is the coefficient of x square. Coefficient of x square. So in this way, the sum of the roots is equal to the negative ratio of the coefficient of x and coefficient of x square. Now we study about the product of the roots. Now you see that we are studying about the product of roots now. Alpha into beta is equal to c over a. So we start with, we know that x is equal to minus b plus minus square root of b square minus 4ac over 2a is our formula for the quadratic equation. If we are taking positive sign, we assume that it is alpha. Root is alpha minus b plus square root of b square minus 4ac over 2a. And if we are taking this negative sign, we get here beta. Root is beta minus b minus root b square minus 4ac over 2a. So these are our two roots. Now we multiply alpha into beta. This is our first equation and this is our second equation. So we multiply equation 1 and 2. Multiplying equation 1 and 2. So we get here alpha into beta is equal to minus b plus square root of b square minus 4ac over 2a. This is the alpha, and beta is minus b minus root b square minus 4ac over 2a. You see what happens now? It is, we know that minus b plus root b square minus 4ac minus b minus root b square minus 4ac. We know that here a plus b into a minus b, this identity a square minus b square. So here a plus b into a minus b, a square minus b square. So minus b square, just a moment, minus b square minus square root of b square minus 4ac square, a square minus b square. In denominator for 2a into 2a, which is 4a square now. Minus b square is now positive b square. Here b square minus 4ac. Why? I explain you. This square and square root will eliminate to each other. And in denominator you see it is 4a square. So it is b square minus b square minus minus plus 4ac over 4a square. So this b square negative, this b square positive. Both will eliminate to each other. And is equal to 4ac over 4a square. So here you see this square eliminate and 4 and 4 will eliminate. Finally we get here c over a, which is alpha into beta. So we have got here alpha into beta, c over a. Now again I would like to explain that you know that the quadratic general form of the quadratic x square plus bx plus c is equal to 0. So here you see c is a constant. So the product of the roots is equal to the ratio of constant over constant over coefficient of x square. Coefficient of x square. So it is the product of the roots is equal to the ratio of constant and the coefficient of x square of the quadratic equation.